If you're deep in the world of generative AI, you know the real monster isn't getting a model to work once. No, the real challenge is making it work reliably, every single time, at scale. Today, we're tearing down the architecture that makes that possible, the LLM evaluation engine. And I want to be clear, this isn't just another tool in the toolbox. This is the new, non-negotiable foundation for any team that's serious about shipping production-grade Gen AI.
All right, let's just rip the Band-Aid off. For decades, our entire CI/CD philosophy was built on this beautifully simple question. Did my code do exactly what I expected? It was a world of perfect, deterministic pass-fail logic. Well, with Gen AI, that world is over. The new question is so much more nuanced and, honestly, way harder. Did the system behave acceptably? See the shift? We're not chasing exactness anymore. We're defining and defending acceptable behavioral boundaries in a massive, probabilistic universe.
So, here's how we're going to break this down. First, we're going to watch the old world of unit tests just completely fall apart. Then, from the rubble, we'll build up a whole new way of thinking, testing behavioral traits, not literal outputs. After that, we'll see the engine in action, showing how it stops that silent killer we all dread, behavioral regression. And finally, we'll hammer home why this isn't just a good idea, it's the new bedrock for the entire field.
Okay, let's start with the crime scene. Why did our old tools fail us? Well, it all comes down to one thing: the end of determinism.
Just picture this. You've got a standard unit test. You feed it the same controlled input you've used 1,000 times.
You run it against the exact same fine-tuned model checkpoint that you spent weeks curating.
You use the very same painstakingly engineered prompt that was working perfectly just yesterday. You've locked down every single variable you can control. And you get a different output, just like that. Maybe the phrasing is a little different, the word order is switched, and your entire test suite, which was built on the fragile hope of exact string matching, just completely explodes.
And here's the thing that really bends your mind at first. This isn't a bug you can file a ticket for. This is the system doing exactly what it was designed to do. This probabilistic creativity is the feature. So trying to shove this beautiful, chaotic system back into our old, rigid, deterministic boxes, it's a complete waste of time. It shows we don't understand the nature of what we're building. We need a new approach.
So if testing the exact output is a dead end, what's left? Well, this is where the big idea comes in. We have to stop obsessing over what the model says and start measuring how it says it. We test its behavior, its traits. This table nails the transition perfectly. On the left, you've got the old world. Brittle unit tests become these rich, complex eval datasets. Rigid assert equals checks are replaced by intelligent, flexible trait scoring. And that simple pass-fail, it evolves into a nuanced decision based on whether the model's behavior stayed within our predefined thresholds. We're swapping out brittle rules for resilient, intelligent guardrails.
So let's be super clear on what this new test suite is. An eval dataset is not a list of questions and their one true answer. Think of it more as a set of scenarios, where each one is paired with the behavioral contract you expect the model to uphold. It's the rulebook for good behavior.
Let's make this real. Say your goal is factual summarization. The input is a dense financial report. Now, do you care if the model says profits rose versus earnings increased? Of course not. What you care about are the traits. Did it make stuff up? The expected trait is hallucination false. Did it get the facts right? Factual accuracy high. We're judging the quality, and we can actually get another LLM to act as a judge, to score these things automatically.
Or, how about a safety example? The user asks for financial advice, which is a huge no-no. Your policy says the model must refuse. So you don't test for the exact words, "I cannot give financial advice." Instead, you test the behavior. Did it refuse? Refusal true. Did it adhere to our policy? Policy compliance true. Now you are programmatically encoding your safety guardrails right into your test suite.
Okay, so we've got this cool concept of testing traits. But how do we get this out of a spreadsheet and into a ruthlessly efficient, automated gatekeeper in our CI/CD pipeline? The magic is machine scoring. For every single response our model gives, the engine scores it across these critical dimensions. We get hard numbers for hallucination rate, refusal correctness, and policy adherence. And my personal favorite, confidence calibration, which basically asks, does the model know when it's out of its depth? These aren't opinions. These are metrics we can track and enforce. And those metrics are what give us control. This line of code right here, this is the whole game. You can literally tell your pipeline, run the evaluation, and if the hallucination rate creeps above 2%, dash fail on hallucination greater than 2%, fail the build. That's it. A pull request that nudges hallucinations to 2.1% gets blocked automatically, no human needed. That is real automated quality control.
So let's look at the whole picture. A researcher commits a change. The system builds an artifact. And then, bam, it hits the gate, the LLM eval engine. This is the moment of truth. Before that code can even think about getting into your main branch, it has to prove, with data, that it didn't make the model behave worse. It's the bouncer at the door of production. Only provably safe changes get in.
And what that bouncer is really good at is catching the most dangerous failure mode in all of Gen AI, that silent, creeping killer we call behavioral regression.
You've heard this before. I guarantee it. Nothing is on fire. There are no 500 errors. The app is up, but the user feedback starts trickling in. It just feels worse now. It's less helpful, a little more annoying, maybe it's hallucinating more. How in the world do you debug feels worse?
You debug it with data. This is what feels worse looks like in a chart. The evaluation engine turns that vague feeling into cold, hard numbers. Look at this. In version 3.1, your hallucination rate was a fantastic 0.6%. Then some seemingly harmless change gets introduced in 3.2, and it quietly quadruples to 2.4%. The engine sees the spike, knows it violates our 2% threshold, and slams the brakes on the release. You just caught the silent killer before it ever got to a user.
Which brings us to the final and most critical point. This whole system, it's not a nice to have. It is the absolute foundation that every single reliable AI system is going to be built on from now on.
I mean, just look at the contrast. Without an evaluation engine, you're flying blind. Upgrading to a new base model is pure guesswork. Your safety strategy is basically just hope. And you only find out something's wrong after the damage is done. But with the engine, everything changes. Every single merge is provably safe. Every change is measurable. And you finally move from just hoping your AI behaves well to actually engineering it to do so. Your system's behavior becomes intentional.
If you walk away with just one single idea today, please let it be this. The entire field of CI/CD for Gen AI begins at the precise moment you stop checking for exact, brittle equality, and you start enforcing flexible, resilient, behavioral boundaries. That's it. That's the whole ballgame.
So I'll leave you with a question to take back to your team. Take a hard look at your pipeline. Can it prove, with data, that the change you're about to merge is behaviorally acceptable? And if the answer is no, you have to ask yourself, should you really be shipping it? Thanks for listening.